Welcome to the first video in the RPG series. In this video we'll create our project, set up our environment, set up a navigation mesh, add controls for our character, and finally make our camera follow him around. Also, thanks to Hans Hoftum for his support on Patreon. If you want to support these videos, you can do so at patreon.com/Brackeys. Lots of stuff to do, so let's get started. Let's begin by opening up Unity. Let's create a new project. I'm going to call it RPG Project. I'm going to select 3D and hit Create Project. Now you can download the environment that I'm going to be using off of dev assets, but feel totally free to use your own models instead. If you download these, you will get a zip file. Simply unzip that, and inside the folder you will see a Unity package. We can then drag this Unity package into our project, hit import, and once it's done importing, you should see a folder called environment. In here we have an example scene, and if we open that, it should set up pretty much everything for us. The only problem here is that the scene is currently very bright in the game view. To change that, let's go to Edit, Project Settings, Player, and let's change the color space from gamma to linear. Now you can see we get much more detail in the lighting, and it's no longer overexposed. By the way, in order to get it looking good in the scene view as well, make sure to enable lighting, and also go ahead and enable image effects. Let's also take our scene and drag it out from the folder. Let's rename this to main, and we can collapse this folder once more. So now we have our environment in the scene. Let's go ahead and create a player character. Let's right click in the hierarchy, go 3D object and then cube. Let's then snap to the top view here so we can see it from above and move it over to somewhere near our spawn location. I'm then gonna hit F to focus on it, and let's bring it down a little bit to the ground. I'm also going to make an empty object under this cube, and this is actually going to be our parent object. So we'll call this object our player, and we'll then take our cube and move that under the player. Now our cube is just going to be our temporary graphics, so let's go ahead and rename that to graphics. Remember, Sebastian will be substituting this with a real character later. Now let's remove the box collider from our graphics, and let's maybe also scale it up on the Y here. Now that we've scaled it up, we also need to move it up, so let's give it a 1 on the Y position. This should give us a situation where the origin of our player is at the very bottom. If you don't see this, make sure that you've enabled pivot up here. So let's again drag our player down. And now we need to go ahead and add a few components to our player. The first thing that we'll be needing, and the most essential thing for handling movement, is going to be a nav mesh agent. This is a Unity component that will allow us to move our player around the scene, and it will automatically handle pathfinding for us. Now the navigation tools in Unity are currently changing, and some new awesome high-level components are being introduced. I'm working on a video focused on navigation, but getting started is actually really easy. First we have to set our speed. Let's just put that to 3. And our angular speed means how quickly we turn. Let's just bump that up quite a bit. I'm also going to bump up our acceleration to 20 because I want our player to be fairly snappy in his movement. Everything else I'm going to leave as is. I am, however, going to add a few more components. Let's add a capsule collider. And we can't really see this because of our graphics, so let's just go ahead and disable those. Now on our player we can see both our agent and our capsule collider. We need to change the height of this to 2 and move it up 1 on the Y. And now it fits nicely inside. Other than that, we can also add a rigid body. And we don't want this to be acting on its own. We want this to only follow around the nav mesh agent. And so we want to check is kinematic. These two are totally optional, but they're really nice if you want your player to be able to push around objects. And I think that's just nice functionality to have. Let's collapse those. Let's turn back on our graphics. And in order to get our player movement, we need to bake a navigation mesh. This is a way to define which areas of our map is walkable and which are not. To do that, we go Window, Navigation. I like to dock it over here by the right. And if we go to the Bake tab right now and simply hit Bake, you'll see that we've already set up all the appropriate settings for this environment. And so we have a nicely baked nav mesh where we can walk on the ground, we can walk over the bridge, and we cannot get too close to trees or other obstacles. The way that we've done this is simply make sure to select all of the models inside of our environment and mark them in the inspector as static. Whenever you mark an object as static, you tell the navigation system that you want this to be included in the navigation mesh. However, the ground here is marked as static, and the same thing for some of the trees, but the ground is walkable and the trees are not. So the way to define that is by going to navigation and then selecting object. And you can see right now I have the ground selected, and the navigation area for that is set to walkable, but for our trees it's set to not walkable. So that's how you can differentiate between the two. You can also see that we have a slight glitch here with our campfire. I think that's because this is set to walkable. So let's select our campfire. Let's go under and select all of these sub objects. And you can see all of these are indeed set to walkable. Let's change that to not walkable. Let's also change the children for a fire. And now when we rebake, we can no longer walk on top of the fire. If you want to add other objects to your navigation mesh, it's super simple. Let's just try and add a cube. Let's try scaling it up and moving it over to the end of our bridge. Now this is clearly something that we don't want to be able to walk inside. So we go to Object and make sure that it's set to Navigation Static. You can also just go to the inspector and enable static here. Then inside navigation, we'll set the area to not walkable. And now when we bake, we can see that the navigation mesh bakes around that object. However, if the object were to move, well, now we get a slight issue. To fix that, we'll make it non-static, and instead we'll add a nav mesh obstacle component. We'll enable carve, and you will now see that inside of our navigation, whenever we move the cube, it will carve out a piece of the mesh at runtime. And to get rid of this, we just need to hit bake. So you can use that for anything that needs to move. Also note that you don't need to have colliders in order for the navigation mesh to be built. So let's delete our cube. Let's go to the navigation tab, and under bake, we have a few settings for our agents. I'm gonna bump up the agent radius to say 0.4 and the step height to say 0.5. Let's now bake. And you can see our settings being updated. Now all there's left to do is go to our player, and here we want to add a few components to control him. Let's hit add component and add a player controller. Let's hit create an add and open it up in Visual Studio. Now we're going to be expanding on this script as we go, but let's start with the basics. First of all, we need a reference to our camera. Let's store that in a camera variable called cam, and in the start method we'll set cam equal to camera.main. Then inside of update we want to check for some input. We want to check if we press the left mouse button, so if input.get mouse button down, and the left mouse button here is 0. So if we press the left mouse button, we want to cast out a ray from our camera towards whatever we clicked on. To do that, we'll create a new ray. Let's just call it ray and set it equal to cam.screenPointToRay. This is a handy function that will shoot out a ray from a point on the screen, and the point that we want to shoot from is our mouse position, so input.mousePosition. We also want to store some information about what we hit, and we'll store that in a rayCastHit variable called hit. Then we can cast out the ray itself. We do that by writing if physics.raycast, and the ray we want to shoot out is ray. We want to store information in our hit variable, and we can add some more parameters, but for now let's just leave the 2. So we're shooting out a ray towards what we clicked on, and if it hits something, everything inside of these 2 braces will be executed. We just want to go ahead and move our player to what we hit, and we actually want one more thing to happen here, and that is stop focusing any objects. I want our player to be able to focus an object. This could be any kind of interactable. Say if he right clicks an item, we want him to focus that item, walk to it and collect it. Or if he focuses an enemy, we want him to walk towards the enemy and attack him. But if we use left click, we just want him to move around. And so we want him to stop focusing on whatever he's doing. So here we want to also stop focusing any objects. So let's begin with the first one. Let's move our player to what we hit. But before we start moving, let's just see if our raycast is working. Let's write out a debug.log saying we hit, and then the hit.collider.name, so the name of the object that we hit, and the point that we hit, so hit.point. Now inside of Unity, if we hit play and click on the ground, we can see that we hit the ground at this point, but we can also click on non-walkable objects, such as the wooden stool here, or the campfire. We don't want to do that. Our movement should really only be focused on the ground. Luckily, we can filter out objects when shooting our ray by using a layer mask. Let's create a public layer mask. Let's call this our movement mask. Down here, when shooting the ray, we can then first of all add a range. I'm just gonna add a range of 100 here, and then our mask. So we'll put in our movement mask. Let's now save this, go into Unity, and now we can define what layers we want to be able to register movement on. Let's go ahead and add a new layer. Let's make this layer the ground layer. Let's then go under our environment. Let's find our ground object and set the layer to ground. And let's do the same thing for our bridge and maybe also our mage circle. All other objects we can simply leave at default. Then under our player, under the movement mask, let's go ahead and select only ground. Now when we hit play, you should see that we can click on the ground still, but it will click right through the wooden stool and the campfire to the place on the ground underneath. Awesome. So now we know where to move. Let's actually move the player. To do that, let's go ahead and create a component called player motor. In here, we want to control our nav mesh agent. To do that, we need to use Unity engine.ai. We also want a reference to our nav mesh agent. So let's go ahead and create a nav mesh agent component called agent. And we'll go ahead and get our agent by going get component nav mesh agent in our start method. Just to make sure that we'll always have a nav mesh agent to get, let's add a require component attribute of type nav mesh agent. So now Unity will automatically add a nav mesh agent whenever you use this component. Then we can go and create a public void called move to point. And we'll give it a vector 3 that specifies the point that we want to move to. Then in order to actually move there, we simply go agent.setDestination. And our destination will be the point. Now currently this script is super simple, but we will be expanding upon it over time. For now, let's just save this, go into our player controller. In here we want a reference to our player motor. We'll do that the exact same way we added a reference to the nav mesh agent. So let's create a player motor variable, call it say motor, and in the start method we'll set motor equal to get component of type player motor. And again we'll add a require component attribute of type player motor. Then when we decide to move to a certain location, instead of writing out a debug.log statement, we'll go motor.move to point, and the point that we want to move to is hit.point. Now let's save this, go into Unity, hit play, and we should now be able to click anywhere in the environment and our player will automatically find the quickest path to that place. It's really fun to play around with, and we can of course update our path dynamically. When building our player controller, we don't only want to be able to move, we also want to be able to focus on objects. To do that, we'll go into our player controller, and in the update method, we'll look for a right click instead of a left click. So we'll use left click for movement and right click for interaction. To do this easily, let's just copy our if statement. The mouse button that we want to look for is 1 for right mouse. We still want to shoot out a ray from our mouse position, but we don't want to use the movement mask. Instead, what we want to do is see if the object we hit is something that we can interact with. To do that, we'll look for a component on the object. Now we haven't created this interactable component yet, but we can just write for now that we want to check if we hit an interactable. If we did, set it as our focus. Cool, so we have our player moving around the scene, and we are registering input for focusing on objects, but our camera is still stationary. To change this, let's select our camera, add a new component, we'll call it the camera controller. Let's say create an add, and in here we want to create a fairly traditional camera controller. We want first of all a transform, which is going to be the target to follow. We'll also have a public vector 3. This is going to be the camera's offset from the target. And finally we'll have a private float, which is going to be our current zoom. Let's just default that to 10. We'll then make a late update method. Remember, late update is the same thing as update, except it's called right after. And in here we'll set transform.position equal to our target's position minus our offset multiplied with our current zoom. We also want to look at our target, so that's called transform.lookat and feed it our target's position. Remember though that our target's position is at the feet of our character. So let's go ahead and add an up vector, vector3.up, and multiply it with some value. In our case, our character is 2 units tall. Let's go ahead and wrap this in a variable called pitch. Then up here, we'll simply make a public float called pitch and default that to 2. Now if we save this, head into Unity, drag our player into the target slot and hit play, we can see that our camera snaps inside of our player. Let's then try and configure the offset. And I think I'm fairly happy with this, so I'm just going to copy our component, stop playing, right click and hit paste component values. Now we also want a way to be able to control our zooming in and out. To do that, we'll go in here and create a public float zoom speed and set that equal to say 4 by default. And we'll also create a minimum and maximum zoom. Our min zoom is going to be 5 and our max zoom is going to be say 15. Then inside of the update method, we'll use input.getAxis to get any changes in our scroll wheel. So the axis that we want to get here is mouse scroll wheel. And we want to multiply those changes with our zoom speed. We then want this to configure our current zoom. So we'll say current zoom. And I know by experience that this should be inverted. So we'll say minus equals input.getAxis. If you want to invert yours, you can simply add a plus sign here instead. Then we'll clamp our zoom, so we'll set current zoom equal to math.clamp. We want to clamp our current zoom between our min zoom and max zoom variables. Now if we save that and hit play, we should be able to zoom in and out, but only to an extent. I also think the fog is getting a bit in the way here, so I'm just going to go to lighting. On the other settings, set the start of the fog to 30 and the end to 40. I think that looks a bit better. So now we can follow the player around the level, but the rotation of our camera is still fixed. Let's create another variable called yaw speed and set it equal to, say, 100 by default. We'll also create a private variable called yaw input and set that equal to 0 by default. Then inside of our update, we'll go and use input.getAxis in order to check if we've used our horizontal axis keys. So if we write horizontal here, that means that we're checking for A and D or left and right arrow keys, or the joystick if you're using a controller. We then multiply that with our yaw speed, and we also want to multiply this one with time.delta time. Then we can store this in our yaw input variable, and down here we can use transform.rotateAround in order to rotate our camera around our target. So we'll give it target.position, and the axis that we want to rotate around is vector3.up, and the angle is going to be our yaw input. I think a better name for yaw input would be current yaw. And right now we've set this directly. That's not what we want to do. Instead, we want to subtract from our current yaw based on the input axis, in the exact same way that we do it with our current zoom. So now when we save this, go into Unity, hit play, we should be able to use A and D to move around our camera. Awesome! Finally, let's go to our project and right click, hit create folder. Let's make a folder called scripts. Let's place our camera controller, player controller, and player motor in there. It's good to stay organized. That's pretty much it for this video. If you enjoyed it, make sure to subscribe so you don't miss a future one. Also, make sure to subscribe to Sebastian's channel as well. He'll be uploading videos on how to do the graphic side of the game soon. And he just has a lot of awesome game development videos in general. On that, thanks for watching, and I will see you in the next video. Thanks to all of the awesome Patreon supporters who donated in June. And a special thanks to Hans Hoftun, Jesper Mikkelsen, Will Goat, Thomas Worley, Stone Gamer, Cyborg Mummy, Jason Latido, Derek Heemskirk, and Faisal Marify. If you want to become a patron yourself, you can do so at patreon.com/Brackeys.